Okay, let us start our lecture. कल हमने वो सिमेट्रिक ग्रुप डिस्कस किया था है? उसके एलिमेंट्स हमने ये भी कहे थे कि वो ऑटोमॉर्फिज्म दैट कैन बी ट्रीटेड एज ऑटोमॉर्फिज्म ऑन फील्ड ऑफ रैशनल फंक्शंस. Today we have following theorem. Let F be a field. Let F be a field and let f of x1, x2, xn be the field of rational functions. Be the field of rational functions. Over F. A rational function is over the field F. Now suppose that this S is the fixed field. Suppose that S is the fixed field of symmetric functions. Fixed field of symmetric rational functions of symmetric rational function. ये हमने कल डिस्कस किया था दिस एफ. ओके, ये एस क्या है एक्चुअली? इट्स अ फिक्स्ड फील्ड विथ रिस्पेक्ट टू दैट ग्रुप ऑफ ऑटोमॉर्फिज्म्स है, वो हमने कल डिस्कस किया था. सो इट इज एग्जैक्टली द फिक्स्ड फील्ड ऑफ symmetric rational functions. Then following holds. First property: the degree of the field f of x1, x2, xn over this fixed subfield of that f of x1, x2, xn, this degree is exactly equal to n factorial. It is the order of Sn actually. Okay? It's exactly equal to n factorial. Second part: the group of automorphisms of the fixed field of the field f of x1, x2, xn, fixing this S. Okay, fixing S is a fixed field. This is equal to S. It's exactly equal to Sn. वो जो Sn की ऑटोमॉर्फिज्म है ना, वही एक्चुअली S के एलिमेंट्स को फिक्स कर रहा है. इट्स नॉट मोर देन Sn. The symmetric group of degree n. Symmetric group of degree n. And the third part is if a1, a2, an, if a1, a2, an, these are the elementary symmetric functions जो हमने already define की है, or the elementary symmetric functions, that means this a1 is equal to x1 plus x2 plus xn. Okay, and then a2 is the sum taking 2 at a time. These are called elementary symmetric functions, and a is the product of these n elements x1, x2, xn. So these are elementary symmetric functions in the variables x1, x2, xn. In these letters x1, x2, xn. Then this fixed field is exactly equal to the smallest field containing f and these symmetric functions. And fourth one is this f of x1, x2, this field of a rational function. This is the splitting field. This is the splitting field. Splitting field over this field f of a1, a2, an, which is equal to s in third part. Splitting field of f of x1, x2 is a splitting field. Splitting field is obviously over certain field. Splitting field is defined for a polynomial which is defined over certain field, and that polynomial is defined over this field f of a1, a2, an. It's the splitting field of over this field of the polynomial this t power n minus a1 t power n minus 1, then plus a2 t power n minus 2 minus, it is plus minus, okay, and finally we have minus 1 power n, minus 1 power n a n. This is the constant term. It is the splitting field of this polynomial. So this is the polynomial over the field f of a1, a2, an, क्योंकि इसके जो coefficients है ना वो है a1, a2, an, and that lies in the field f of a1, a2, an. ये है theorem आपकी जिसके 4 parts हैं. Now let's try to prove this theorem. Proof. Proof of the theorem. Since this Sn is the group of automorphisms, Fn is Sn is a I will erase this page. Proof. Since Sn is a group of automorphisms, of the field f of x1, x2, so on xn, and leaving this Sn, it leaves as fixed, जो S को फिक्स कर रहा है. What's S is actually the fixed field, है ना. S is actually fixed field. ये हमने कल डिस्कस किया था. What's S actually? It's actually the field of symmetric rational functions. This S is the field of symmetric rational functions in f of x1, x2, xn. f of x1 x2 xn is the field of all rational functions, but S is the field of symmetric rational functions. So it means that every member of Sn fixes S, क्योंकि Sn में ऑटोमॉर्फिज्म्स है और ऑटोमॉर्फिज्म जो भी है वो सिमेट्रिक फंक्शंस को फिक्स कर रही है. सो Sn का हर कोई मेंबर S को फिक्स कर रहा है. सो देयरफॉर we must have this Sn must be subset of this group G x1 x2 xn with this S. तो इसका मतलब क्या है? इसका मतलब है कि वो सारी ऑटोमॉर्फिज्म जो S को फिक्स कर रही है और Sn में जो भी मेंबर है वो S को फिक्स कर रहा है. इसका मतलब है Sn इसका सबसेट है. Sn इज द सबसेट ऑफ दिस बिकॉज एवरी मेंबर ऑफ Sn फिक्स. ये हमने कल के लेक्चर में डिस्कस किया था. एवरी मेंबर ऑफ Sn फिक्स एवरी सिमेट्रिक फंक्शन. Okay, and S is the fixed field. S is the field of symmetric functions. So this thing is subset of. Now we can apply the theorem जहाँ पर हमने वो order निकाला था. What is order of S? This order of Sn. Now this n factorial, it's equal to order of Sn. And this Sn is subset of this group of automorphisms, so it's less or equal to order of this group of automorphisms fixing S. Okay, this thing. But this order is less or equal to the extension, this degree of f of x1 x2 xn over this symmetric over this the field of symmetric rational functions. This we have done. This order of G हमने actually prove किया था. Order of G के f is less or equal to the degree of f, degree of k over f, degree of k over ये result है given हमें. Order of G k f is less or equal to डिग्री ऑफ k ओवर f. ये रिजल्ट हमने किया है. और यहाँ पर हमारा जो k है ना वो है f ऑफ x1 x2 xn और जो f हमारा है दैट्स s. सो एक्चुअली वी वांट इक्वलिटी. हमें इक्वलिटी चाहिए बट दिस इज थिंग इज लेस और इक्वल टू दिस. ये हमने एक साइड से हमने इसको किया है. वी प्रूव एक्चुअली इक्वलिटी. इक्वलिटी अगर हमने प्रूव किया ना तो ये सारी पार्ट्स उसी से आ जाएगी, ऑल द पार्ट्स, अगर हमने सिर्फ इक्वलिटी को प्रूव किया. इसका नाम आप 1 रख दीजिए. नेम इट 1. नेक्स्ट वी शो दैट this degree of f of x1 x2 xn, degree of f of x1 x2 xn over the field f of a1 a2 an, this degree is less or equal to n factor. ये हम प्रूव करेंगे. ये less or equal to n factorial है. तो वहाँ से आप देख सकते हैं, वहाँ से ये कंक्लूड होगा डिग्री ऑफ f of x1 x2 xn ओवर s is also less or equal to n factorial. अगर हमने ये प्रूव किया तो सबसे पहले हम ये प्रूव करेंगे, इसके बाद हम ये इस रिवर्स इनइक्वालिटी को देखेंगे. जो हमें 1 की जो रिवर्स इनइक्वालिटी है ना वो हमें एक्चुअली प्रूव करनी है. तो उससे पहले हम इसको प्रूव करेंगे f of a1 a2 an. सो डिग्री ऑफ f of x1 x2 xn ओवर द फील्ड f of a1 a2 an is less or equal to n factorial. इसको प्रूव करने के लिए हम पॉलिनोमियल लेंगे इन f of a1 a2 an. लेट्स कंसीडर अ पॉलिनोमियल. कंसीडर दिस पॉलिनोमियल. Consider the polynomial. Okay, must erase this. Consider the polynomial P of t, which is equal to t power n minus a1 t power n minus a1 t power n minus 1 plus it's minus 1 power n a n. Consider this polynomial over the field f of a1 a2 a n over this field. And we try to factor the polynomial P of t, this polynomial factors into linear factors over the field f of x1 x2 xn as this P of t is actually equal to t minus x1 t minus x2, because these x1 x2 xn, these are the roots of this polynomial P of t. a1 is the sum of the roots, then a2 is the sum taking 2 at a time, and so on and so forth. आप इसको चेक कर सकते हैं n equal to 2 के लिए, वहाँ पर आपके पास a1 और a2 सिर्फ होगा, a1 होगा x1 plus x2 और a2 है x1 x2. So then that polynomial t square minus a1t plus a2 can be written as t minus x1 into t minus x2. So in general, for n, this polynomial can be factored into linear factors like this t minus x1 t minus x. और ये linear factors किस में है? They are not in the field f of a1 a2 a, they are in the field f of x1 x2 xn. So that's why this polynomial can be factored into linear factors over the field f of x1 x2 xn. तो इसमें इसके सारे रूट्स है, f of x1 x2 xn में इस पॉलिनोमियल के सारे रूट्स है, क्योंकि इसके रूट्स है x1 x2 xn, और वो फील्ड जो आपके पास है f of x1 x2 xn, ये फील्ड इन रूट्स को कंटेन कर रहा है. So we see that this is actually the splitting field. हम ये शो करेंगे ये एक्चुअली splitting field इसका है. This is the splitting field of this polynomial. ये हम चेक करेंगे. रूट्स तो कंटेन करता है और इसको फैक्टर भी करता है लीनियर फैक्टर उसमें. ये splitting field की पहली प्रॉपर्टी है. सेकंड प्रॉपर्टी है कि दिस शुड बी द लीस्ट फील्ड. ओके, there should not be any field which is properly contained in that field f of x and x to x and factors the polynomial into linear factors. अगर ऐसा होगा, कोई और फील्ड नहीं होगा जो f के अंदर प्रॉपरली होगा और p of t को फैक्टर करेगा लीनियर फैक्टर्स में, तब जाके आपका जो f of x1 x2 xn है ये इसका स्प्लिटिंग फील्ड होगा. तो उसको हमें एक्चुअली आंसर करना है इस क्वेश्चन को. Okay, so there does not exist as a field, there does not exist a field which contains the field f of a1 a2 an and splits completely or splits p of t into linear factors. Splits p of t into linear factors. क्योंकि इसके रूट्स हमें पता है, इसके रूट्स x1 x2 xn है, तो अगर ये स्प्लिट होगा लीनियर फैक्टर्स में तो वो इसकी फॉर्म फिर ये होगी t माइनस x1 t माइनस x2 t माइनस xn। फॉर इफ पॉसिबल, फॉर इफ अगर ऐसा होगा, फॉर इफ पॉसिबल इट हैपन्स, for if possible it happens, then for if it happens, then say for if possible, मैं इसको ऐसे लिखूँ, for if possible, okay. It is here linear, okay, linear factors. For if possible, there exists a field. For if possible, there exists a field K. There exists a field K. Okay. There exists a field K. There exists a field K such that this thing f of a1, a2, an is subset of K, and K is strictly contained in f of x1, x2, xn. Suppose ऐसा है, then this K, then K must contain f and x1, x2, xn, क्योंकि और k स्प्लिट हो रहा है, तो इसका मतलब है ये जो x1, x2, xn है ये k के मेंबर्स होने चाहिए, क्योंकि फैक्टर्स आपके पास क्या है, t माइनस x1, अगर ओवर दिस फील्ड k होगा तो उसके जो कोएफिशिएंट्स होंगे वो k के मेंबर्स होने चाहिए, और t माइनस x1 का कोएफिशिएंट सिर्फ एक है, दैट्स x1, दूसरा कोएफिशिएंट इसका 1 है, t का जो कोएफिशिएंट है वो 1 है, और कांस्टेंट टर्म उसमें x1 है. So then that field must contain these. Okay, but this f of x1, x2, xn is the smallest field containing these x1, x2, xn. It's the smallest one because it's the field of quotient of f of x1, x2, xn. It's the field of quotients of x1, x2, xn. So but then this k should be equal to f of x1, x2, xn as f of x1, x2, xn is the field of quotients, quotient means it is the smallest one, field of quotient of this one जो इसको कंटेन करे f of x1, x2, xn को. So therefore there is no any proper subfield of k, which is a contradiction, क्योंकि हमने ऑलरेडी माना था k इसके बराबर नहीं है, तो यहाँ से k इसके बराबर आ गया, which is a contradiction, thus f of x1, x2, xn is the splitting field of p of t over the field over this f of a1, a2, an. It is a splitting field of this polynomial. Okay, therefore what is this degree? Over f of a1 a2 an, this degree, ये डिग्री क्या है? This p is a polynomial over this field, and this one is a superlative field, okay, of that polynomial. Then we know that this thing is less or equal to the n factorial. This is a result that you have already done. This thing is less or equal to n factorial. This thing is less or equal to n factorials. Okay. Now let's see this. Actually we want to find f of x1 x2 xn over s. ये हमें निकालना है असल में. Okay. So now we find f of x1 x2 xn, degree of this over s. ये हम चेक करेंगे. This s contains the field f of a1 a2 an. Okay, this s contains that field. So this one is equal to this one. Okay, not this one. Actually, it's here. Degree of this over this, over f of a1 a2 an. This one is equal to degree of f of x1 x2 xn over s into degree of s over f of, because s is a field lying between f of x1 x2 xn and f of a1 a2 an. This thing. Okay, yeah. This you have seen that this thing. You can start now. You can start with n factorial. Actually, n factorial greater or equal to this. Na? Now this you can write here. N factorial is greater or, जो आपने ऊपर देखा, n factorial is greater or equal to this degree, and this thing is equal to that one. But this one f of x1 x2 xn, this we already seen by 1 f of x1 x2 xn over s. This is this thing n factorial is greater or equal to this. So okay, this is greater or equal to this, but this one is also greater or equal to n factorial. This is greater or equal to n factorial into degree of s over f of a1 a2 an. आप जरा 1 देखिए, by 1, it's by 1. स्टार्टिंग में जो आपने लिखा ना वो inequality 1. Okay, so this f of x1 x2 xn over s is greater or equal to n factorial. It's greater or equal to n factorial. तो हमने n factorial से start किया और n factorial into this number. So it means that this should be equal to 1. So because it gives that n factorial greater or equal to n factorial into this, which means that this thing should be equal to 1, this s into f of a1 a2 an. Because if it is suppose greater, suppose it is 2, then n factorial is greater or equal to n factorial into 2. N factorial or n factorial को cancel कर से you will get 1 greater or equal to